of reflection. To understand the first law of reflection, we need a screen and a plane mirror beneath it. When we throw a beam of light on the surface, it is known as incident ray, and when the same ray comes back from the surface after reflection, it is known as reflected ray. So the first law of reflection states that the incident ray, reflected ray, and the normal, which is formed at the point of incidence, lie in the same plane.
To demonstrate the second law of reflection, we need a screen, a protector fixed on it firmly, and a mirror beneath the screen. So when I flash the light from 40 degrees, it passes through the screen and falls on the smooth surface, which is the mirror, and is reflected back at 40 degrees. Hence we can conclude that angle of incidence equals to angle of reflection.
This bottle will provide water with the help of this pipe. This pipe is blocked so that no air should come in the bottle. If I open the cap of the bottle, the air will start coming and the water will be flowing through the pipe like this. And if I close the water cap, the air will be blocked and no water will be passed through the pipe. So thank you.
So here I have made a simple electric circuit which is connected to these two wires, which when are dipped in distilled water solution, it does not conduct electricity and the bulb will not glow. But when I dip them in solution of common salt and distilled water, the water gets free ions dissolved in it, which makes it conducting and the bulb will glow.
I have made this out of cardboard and attached small pieces of straws on the fingers, and I have attached strings in the small pieces of straw so that when I pull the strings, the fingers move. As you can see, when I pull the strings, the finger moves. I can also grab some things with its help.
You can see I have put a coin under the glass. So when I put water in this glass, the coin seems to be disappeared. This is because of the refraction of light. Refractions occur because water is denser than the air, so when light passes through the water, it bends. As light travels from the coin through the water and the sides of the glass, it is refracted and never reaches our eyes, which is why the coin seems to be disappear.
So, as you can see, the water bottle is filled with water and it has a hole. The water is not going out because of the air pressure, because there is no air passage in the water bottle. So if we open the lid of the water bottle, you can see that water is coming due to air pressure. And if we close the lid of the water bottle, there is no water. So that's the activity to show you about the air pressure.
Wood and one coin to do this experiment, and we will put with this wood in the water and this coin in the water. So we see that in this, wood floats on the water and coin does not float on the water. The reason is because in water is determined by the ratio of its weight compared to its volume. Ratio between the weight and the volume is.
You can see I have made a water tank alarm. When the water is filled, the bulb will glow. This is the baseline on which the water gets alarmed. This helps you to save water. It was done because this circuit was cut, and due to the water it is joined again.
Nail into water, it will sink, whereas this plastic cap will float on it. While talking about some objects, why something sink or float in water, we don't look at its weight or size. The thing we must look upon is its density. Density is mass per unit, that is m upon v. As we can see in first figure, the particles are packed tightly, means not much space is left between them. That means density is higher. whereas in the second one, the density is low because particles are loosely packed. The density of water is 1 gram per centimeter cube. Things having less density than water can only float on it. Example, food. Whereas this metal coin is having higher density, so it will sink in water like the nail. Thank you.
Hello everyone, today Ayuvika of class 8B is here to show you one science experiment. For this experiment, we need a potato, 2 iron nails, an electric wire and a bulb. First we need a potato. Cut the potato into 2 equal halves. Then place the iron nails into it. Now we need an electric wire. Place one end of the electric wire to any of the iron nail. And then we need a bulb. Connect both the ends of the electric wire with the bulb. If we connect the second end of the electric wire with the another nail which is on the another half of the potato, the bulb would glow. This activity indicates that potato has electric current in it. Thank you and have a very nice day ahead.